Hello everyone, it's Mr. Slomka here, and today what we're going to do is we're going to talk about section 5.2, which is on applying congruence in triangles. So last time we had seen each other, we had spent a little bit of time talking about congruent figures, so let's review that topic. Congruent figures are going to be figures where all parts of one figure are going to be congruent to the corresponding parts of the other figure. So now when I'm talking about these corresponding parts, what I really mean is that all corresponding angles are going to be congruent and all corresponding sides are going to also be congruent. And so we're going to be looking for a lot of detail right here. We're going to want to know a lot of facts about the angles and a lot of facts about the sides. Let's take a look at an example problem like that. So if you take a look at this first example, you'll see that I have two triangles that are drawn, and I want you to notice how many marks there are. There are a ton of marks on there. And so we're going to go through each of those, and then we're going to see if we can determine if these are congruent figures. Write a congruent statements for the triangles. Identify all pairs of congruent and corresponding segments, angles, and the triangle itself. So let's start off with what we've got going on here. So to begin with, I want you to notice that we have got some congruent sides. And so one of the first ones I want to look at is this one that has a single tick mark right here. That is side AC or CA. And it is going to be congruent to our second side that we have over here in our other triangle that is marked with the same kind of tick mark, which is FH. Let's find another set. So now I'm going to move on to this double tick mark set right here. That is going to be side AB. And there's going to be another double tick mark over here on our second one, so I'm going to call that one FG. And then I have a third side right here that has three tick marks on it, which is this guy right here, and I'm going to call that one BC. And BC is going to be congruent to the other side that is going to have the three tick marks, which I'm going to call GH. Okay, now let's see if we can come up with another set of information as well. This time it's going to be about angles. So now let's go through our angles. I'm going to start off with my right angle, which is going to be angle A. And angle A is going to be congruent to my other right angle, which is angle F. I'm going to take a look at my smallest angle, which is angle C. It's got the double tick. And angle C is going to be congruent to the one that also has the double tick, which is angle H. And then lastly, I'm going to go to my medium-sized angle, which is angle B. It has a single arc on it, or single tick. And that is going to be congruent to angle G, which also has the single arc or the single tick. Okay, so now the reason I ran through this is because I actually want to count it off. So let's take a look at how many facts that I have collected so far. So we have 1, 2, 3, 4, 5, 6. In a triangle that has three sides and three angles, I want you to notice that every set of sides has got a congruence fact, and every set of angles is going to have a congruence fact as well. That's 6 facts that we've collected so far. Once you have all 6 of those facts, then you can make the statement that both of the triangles themselves are going to be congruent to each other. So now let's name these. When you're naming your triangles, just like when we were naming our sides and our angles, we want to be extra careful to make sure that everything is going to go in the right spots. So for my first triangle, I'm going to be pretty boring about it, and I'm going to call it ABC, which is, I'm going to guess, the same kind of name that most people would use to name this triangle. When I go to my second triangle, I want to make sure that I follow the same type of order. When you're naming these things, you can rotate in the clockwise direction or you can rotate counterclockwise, but I want you to be consistent and I want you to flow around the shape in the same kind of way. When I first did mine, I started here at A, which means I started at my right angle. Then I went across the double tick to my medium-sized angle, which is B. Then I went over the triple tick to my smallest angle, which was C. I need to follow the same exact pattern with my second triangle, which means I need to start with my right angle, which is F. Then I have 2 different directions that I could go, but I want to follow the same direction they went before. I went across the double tick, so I'm going to go from F to G. And then after I had done that, my last move was to go across the triple tick, and so I'm going to do that as well. I'm going to go from G to H. It has to be in this order. You cannot rename the triangle in a different order. It has to follow so that A and F match together, B and G match together, and C and H match together. This is easily seen within our angles. A and F match here, and A and F here match here. C and H, C and H, and B and G, B and G. Everything is in the same spot because the pieces are going to correspond. So corresponding parts, once again, are going to be the pairs of sides of the angles that are congruent when the two figures are in fact congruent themselves. Excellent. So now that is a triangle right there. You need 6 pieces of information, then you can state that your three-sided shape is going to be congruent. They are going to be congruent figures. Let's bump it up a little bit. So now what we have is we have a four-sided figure going on. And what I'm going to do this time is I'm going to tell you that they're congruent. So I'm going to give you this piece of information right here, which is going to say that QRST is congruent to WXYZ. So these two trapezoid type shapes that we've got going on right here are going to be congruent to each other. That means that every set of corresponding angles are going to be congruent. Every set of corresponding sides are going to be congruent as well. So now for the first part of this problem, it says that they want you to find the value of x. Now x is going to be a variable. And I notice that I can find x in two spots. I can find it here, and I can also find it there. Now, even though there are two spots right there, there is one that is definitely better than the other. The better choice is going to be the one that just has the x variable in it and does not have the y variable in it as well. So I'm going to be focusing on this angle right here, which is angle W. So I've got that part pulled out right here. Then what I need to do is I need to find another angle that is going to correspond with it in my other shape. Now if you notice in my other shape I have quite a few angles that are labeled, so I'm going to have to choose the right one. Now here's the easiest way to do it. It's actually not to look at the picture so much as it is to look at the congruent statement right here. The angle that we just got done talking about was angle W, which is at the very beginning of my congruent statement. So when I want to match it up with it, I'm going to go to the very beginning of the other side of my congruent statement. Angle W and angle Q are going to correspond. So that means that my 5x plus 5 is going to correspond with the 65, not the obtuse angles that are listed above it. Now once you've got your angle all set, now you can start to solve. And so we're going to use our regular algebra solving techniques like opposite operations in order to get this answer as quickly as we can, and hopefully without too much stress or problems like that. So when we do that work right there, we are going to end up with an x value of 12. The next problem is going to be yours, and what you're going to do is you're going to be wanting to find the y value. So here's my one hint to you before you pause the video and try it on your own. I would recommend that you take your x value that you just came up with and plug it into the problem as well. We're going to start off with our y minus 6, or y minus x, and that y minus x right here is a side length, which is wx. Now wx right here are the first two letters in one of my congruent statements, so I want to match it up with the side that is represented by the first two letters over here, which would be qr. That is the side length of 6. Now once I've got the 6 there, that's great. I also want to plug in my x value as I had stated earlier, so I've got my 12 plugged in there as well. Then after that, I'm going to solve and I'll get my y value of 18. Okay, in section 5.1 we had also talked about the Triangle Sum Theorem, and we're going to kind of take that a little bit further with another theorem called the Third Angles Theorem. So now we already know that when you have a triangle, all three of the angles have to add up to 180 degrees, which means that's going to really kind of limit you. There's only certain values that could possibly work well together, and so that's good news. So this Third Angles Theorem says that if you already have two triangles and you know that there are two sets of congruent angles, that means that the third set has also got to be congruent. There's no other choice. It has to be that way. So on your drawing, that means you can confidently mark that third set without having to worry about it or feel confused or apprehensive. You can even make that congruent statement as well. If you already know that you have two sets of congruent angles, your third set of angles, which in this case would be angle C and angle F, you can confidently say that these two angles will also be congruent, and you don't have to worry about it. That is going to be by the Third Angles Theorem. How do we know this? Well, we know this by the Triangle Sum Theorem. So the Triangle Sum Theorem is the one that we had spent time talking about in section 5.1. And the Triangle Sum Theorem stated that, once again, if you have three angles in a triangle, those interior angles will add up to 180 degrees. And that means that if you already have got two, then that third one is going to really be limited. And so that Triangle Sum Theorem is going to be able to take us to this spot right here, which is going to be really, really helpful. Okay, let's try a little example problem that's going to use that kind of fact. So right up here, what I have is I have got some more triangles, and what I want to do is I want to try to find the measure of angle V, I should say. Angle V is going to be living right up here, and so we're going to try to see if we can figure out what is the number that is going to live in that spot right there. So let's see if we can do it. I notice that I've got a triangle over here, and I've got another triangle over there, and so I'm going to try to focus in on these two triangles that I'm looking at. There are more triangles in the figure as well, but I'm going to try to simplify things for myself and only focus on the pieces that seem to be related to one another. So I'm going to focus on those two triangles, and I'm going to avoid some of this bottom portion that I don't necessarily need at this point. Okay, let's see if we can get some information kind of translating back and forth. So I noticed that these two angles are currently marked as being congruent. This one is also marked as 66 degrees, which means that this guy over here is going to be 66 degrees, which is fantastic. There is another set of congruent angles as well that is more subtle. So if you take a look right here, we have this 44 degree angle, and that is going to be beneficial to us. We should try to bring that over to the other side as well. This angle over here on the left side will translate nicely over here onto the right side, and we'll have another 44 degree angle over there, and the main reason why is because of vertical angles. So vertical angles are going to bring that over there right there. Our third angle that we need right here, angle V, that angle is going to be our third angle, and so that means we can use our third angles theorem. Anything that can exist up here for angle S is going to translate over here for angle V, and so that we'll get our answer. As I was stating earlier, the third angle theorem is very closely related to the triangle sum theorem. If I use my idea of 180 and I subtract from it the 66 and the 44 that we were talking about earlier, we can quickly and easily get the value that we were looking for, and it turns out that the measure of our angle is going to be 70. So 70 degrees is the measure of angle V. Now also, when I was doing this, I was building these congruent facts right here, so we're working towards creating these congruent figures. If I was going to name these two shapes right here, and I wanted to make sure I was naming them in order just to get a little bit more practice, I would call maybe this first one, I would maybe call it STU. And when I would name my second one, I would want to name it in that same order. So you would want to stick with that newest angle first, then you would want to drop down to the 66, and then end on the 44. So I would call this one over here VWU. So STUV, that's alphabetical order. It works out really, really nicely. And so a lot of times when people start to see that alphabetical order, they just always want to use it. That's not necessarily the case with this one, the second one right here. The alphabet doesn't go VWU, but that's okay. That is fine. That is important that we follow the way that the angles are listed, not just because we like the order of the letters. So we're going to be extra careful on that. Okay, I have two more examples like that where I'm going to ask you to find a variable and then also practice writing those congruent statements. So see if you can work on these two examples right here. Here's your first one. So if you take a look at this guy right here, we're going to be able to translate that 65-degree angle to both of the triangles, and we can also use that x variable on the angle, and we can translate to both of the triangles there. I'm going to use my triangle sum theorem, and once again find my angle measure, which is 25. My top triangle I decided to name ABC, and that is very simple and boring and great. My bottom triangle I also had to label in the same order, so I needed to start with my smallest angle, which in this case was F, and then I wanted to move to my right angle, and then I wanted to move to my medium-sized angle. Let's do the other one as well. Our other problem is right here. Once again, you have some information that is translating very quickly and easily. We've got the 70-degree angle, and I can bring that guy over. He is going to also be able to bring this 60-degree angle over here, but that's a little bit less beneficial because we're kind of focused on this x variable. So once again, I am using my triangle sum theorem. I'm going to subtract the 70-degree angle and the 60-degree angle that I already know about from my 180, and that's going to give me 50. So I know that this angle right down here is going to have to be 50 degrees. Unlike the other problems, though, this angle is not represented by just x, but rather represented by 2x. So I'm going to now take it a step further, and I'm going to set my 50 equal to 2x, and I'm going to solve for x. When I'm naming this, once again, I get to name the first one any way I want, and so I'm going to usually be pretty boring, and so I'm going to call it ABC. That means I went from my unlabeled angle to my single tick to my double. When I name my second one, I want to follow that same kind of order, so I'm going to go from my unlabeled angle, or my variable one. Then I'm going to go to my single, and then my double. And once again, the second one is not in alphabetical order, and that's okay. It doesn't have to be in alphabetical order. In fact, the first one doesn't have to be in alphabetical order either. I just know that that is a popular choice for many, many people, and so I wanted to give you that opportunity. All right, on to the second page of our notes. Right here, what I wanted to do is I also wanted to talk to you about some of the properties that are going to also help you out with these kinds of problems. And I wanted to remind you of some oldies. So some old properties that we have talked about in the past that are beneficial are the reflexive property, the symmetric property, and the transitive property. Now these properties we've used with sides or angles before, and even with numbers and other kinds of symbols, but what we want to do is we want to try to translate that to other things. So we can continue to use it with segments, we can continue to use them with angles as well, but you can also use them with the actual figures, or in this case the triangles. The triangles are the figures that we're going to spend the most time on. Reflexive property, just to remind you, reflexive property states that something is congruent to itself. So I want you to notice that we have ABC is congruent to ABC right there. You can also mix up the order of the letters, and that's fine too. That's still the reflexive property, so we're still talking about the same triangle that has the same vertices, even though we might call it BAC instead of ABC. Symmetric property is going to state that if you have ABC congruent to DEF, that you can flip the order of that, and that works out just fine. A lot of times symmetric property is usually used in order to set you up for the final one, because when you're using this final option, order is important. Transitive property states that if you have, once again, that congruency, ABC is congruent to DEF, but then you also find out that DEF is congruent to a second, or a third triangle, I should say, GHI, then you can skip this middleman right here, and you can get yourself a brand new fact by jumping from the initial hypothesis to the final portion of the conclusion. And so that is going to give you a new fact that we have right here. Once again, transitive property order is important. You see that DEF show up at the end of one statement and at the beginning of the second statement, and that is why symmetric property helps out with that one quite often, because it gets the terms into the right spots. Out of all three that we have right here, the one that is most important, the one that we'll use the most often in Chapter 5, is the reflexive property. Reflexive property is going to be key, and I'm going to show you why in these next two examples. So what I have right here is I've got a couple of triangles. And what I want you to do is I want you to see if you can write a congruent statement and then also talk about the reflexive property. So we do have two triangles right here. One of the triangles is going to be the top triangle that we have here. I will try to mark it in red for you. And then we are going to have a bottom triangle as well. And when you're marking these triangles, when you're looking at them, something I want you to notice is parts of the triangles, corresponding pieces, are going to be utilized more than once. So specifically, if you were paying close attention to this diagonal right here, you'll notice that I marked it in both red and in blue. This is a very particular diagonal, and it's very, very beneficial. So we are going to be spending a lot of time talking about that guy right there. Okay, so now the two triangles right there, if I want to talk about congruence, my first one that I chose to name is I called it ABD, so I've set that up for you, ABD. So I'm starting here at my smallest angle, I'm going across to my right angle, and then down to my medium-sized angle. When you name your second triangle, you need to follow the same pattern. So we're going to start here at our smallest angle, which is D. Then we're going to come to our right angle, C, and then up to our medium size, A. DCA is going to be the only name that can possibly go there. Okay, now the reflexive portion. Remember that when you're talking about triangles being congruent, all of the angles need to match. All of the side lengths need to match as well. And out of all these things that we have, the set that is easiest is actually this set right here. This set is the hypotenuse. It is the longest side of both of these triangles, and it is going to be shared by both, so that means it's congruent to itself. This is where the reflexive property is really going to come into play. We get to say that AD is going to be congruent to, you can call it AD again, or you can call it DA. I'm going to choose to call it DA. To itself, and that reflexive property is going to really benefit us. The same kind of thing can be said about these two triangles right here. So if you take a look at these ones, let's take a look at our first triangle. The first triangle they want us to look at is AEC. So I'm going to be marking that guy off right here. I really think that it is beneficial when you're first working on problems like this with these overlapping triangles that you actually highlight them or mark them off in some way. Once you see the colors, it's going to allow you to kind of see the overlap a lot easier. So marking it is crucial. Now the second triangle, I want it to look very similar to that, have the same side lengths and have the same angle measures, but exist in a different spot. That would be this triangle right here. As I'm marking it off, once again, the things that you want to look at is you want to look at the parts that are going to be marked in both colors. Those are the ones that are going to be shared, and those are the ones that we're going to talk about with respect to the reflexive property. Let's name it first, though. So my first name that I had was, once again, AEC. I started here at the very top, and I flowed down to the farthest point, E, and then back towards the middle. So when I'm naming my blue triangle, I want to follow that same kind of pattern. I want to start at the very top, so I'm going to start at A again. and then we're going to come down here to point F, and then we're going to come back to point B. There you go. Certainly not alphabetical order. Okay, now let's talk about the reflexive part. So if you're looking at this picture right here, I want you to notice that they have overlapping segments, but some of the segment portions are short and some of them are long. So the segments are not overlapping in the exact type of way. The part that I want to focus on more, though, is this angle right here. This angle is marked in both blue and red, which means that is the angle that I am most interested in. Now, as we've talked about before, when you're naming angles, you can technically use one letter, but it is much safer to use more. So I'm going to name my angle two ways. I'm going to first name my angle based off of my red marked triangle, and I'm going to call it CAE. Then I'm going to name it, and this time I'm going to mark it off based off of my blue triangle. I'm going to call it BAF. It is the exact same triangle. It has the exact same vertex, which is key. But the way that it looks is quite different. We're using different letters each time, but it is the same angle both times. So that is the reflexive property right there for both segments and angles. Okay, let's see if we can write ourselves a proof. So this is going to be our final piece for the problem right here. What we have right here is we've got our very large given statement. The reason why this given statement is so big right here is because, once again, we are looking for 6 facts. I need to find 3 sets of congruent sides, and I need to find 3 sets of congruent angles. Now, if you take a look at what they've done, is they've already given me 2 sets of congruent sides, so that's all taken care of, and I like that a lot. And then they've also given me 2 sets of congruent angles as well. So a lot of the work is all taken care of for me just in the given, but not enough. Once again, I need 6 facts, I need 3 sets of segments, and I need 3 sets of angles. So let's do some more. You can choose to attack the segments first, or the angles second, or the angles first and the segments second, whatever makes the most sense for you. I'm going to choose to do segments first, and the main reason why is because they chose to do segments first. So I already have my sets of segments marked as congruent. My last set of segments that I'm going to need is, not surprisingly, and this is going to become a very popular option, is the reflexive set that is right here in the middle. Segment GH is going to be congruent to itself. GH is a segment that is shared by the triangle on the left side and the triangle on the right side, so it's easy to make the statement that it is congruent to itself. And this is going to be, once again, the reflexive property. This is going to be our number 1 property that we're going to be using from back in the day. Now, for our other piece, that is now going to bring our segment total up to 3. So we have 1 segment, 2 segments, and now 3 segments, so we are looking pretty good. We also need to have the same kind of information for our angles. We already have 2 sets of angles easily marked off here in our picture. There is a 3rd set of angles that you can clearly see here, and we should do those as well. I'm going to choose the name of the angle over here on the left. I'm going to call it HFG. Once again, you could probably name it with a single letter, but that's a bad habit to get into. I'm going to call this one over here on the right HJG. And the reason why I can state that these angles are now going to be congruent to each other is a brand new theorem that we learned today. This is my 3rd set of angles, and the reason for saying that these 3rd set of angles is going to be congruent is the 3rd angle theorem. So this is going to be a really great way to use that new theorem that we just found out about today. Alright, so now I have, once again, 3 sets of angles and 3 sets of sides that are all marked as congruent, so that means it is now officially time to wrap up this proof. Even though I was looking for 6 pieces of information, it's not a 6-step proof, but I do have 6 congruent signs so far. My last step is going to be the proof statement, which is right here. I want to state, and I'm going to have to copy it exactly how I see it, triangle FGH is congruent to triangle JGH. Now, why are these 2 triangles congruent to each other? We don't have a triangle congruence theorem. That is not something that exists, but we do have, once again, our congruent figures theorem. So we're going to be able to state this is going to be congruent to each other by congruent figures. Congruent figures is going to be a little bit more general. That means it'll work for 4-sided shapes or 5-sided shapes as well as 3-sided shapes. We're typically going to use it on triangles because they're a little bit smaller and simpler, but you can use it on larger shapes as well.